Okay. I want to take 1 second to come back up here. All right. And just go through these steps one more time to try to cement it into your head, especially now that we're going to get into the more complicated problems. So the first thing we're doing is isolating the absolute value term. I'm indicating when I've done that with a check mark. Then I'm setting up two equations. The isolated absolute value equal to what's already there, and then the isolated absolute value equal to a negative number. These two numbers should be opposites. I'm solving both equations, and I'm generating two solutions. So we can see that in both of the problems that we just started with. Any questions? No questions. Perfect. Okay, so let's move on to 3 and 4. So for number 3, if I draw on my wall and I highlight my absolute value, I need to do the same thing I've done before for solving for a variable. So one time I'm going to show you this, and I'm going to use a pink pen to show you this. If this had read 3y minus 1 equals 29, and I said solve the equation, I'm pretty sure most of you would know how to do the plus 1, 3y equals 30, and you would get y is equal to 10. Okay? Keep this process in mind, because instead of solving for the variable y, I'm going to solve for this quantity, which is the absolute value. So I'm going to add 1 to move it to the other side. I'm then going to once again consider this is the unit that I'm isolating. So I'm going to divide both sides by 3. That's multiplication out front. I am then going to solve this by setting up two absolute value equations. So at this step right here, I have accomplished step number 1, isolating my absolute value term. The math of this is modeled over here in pink with a single variable. This problem doesn't have a single variable. So notice I have y equals 10, but down here I have absolute value is equal to 10, which is my goal. Now I can set up two equations. So my two equations are going to be 5x plus 20 equals 10, and 5x plus 20 equals negative 10. What is inside absolute value is never touched. That stays the same on both of these equations. Only the other side changes. So now I can solve this. I'm subtracting 20 from both sides. Here's my little wall. 5x equals negative 10. X is going to equal negative 2 when I divide everything by 5. Minus 20. X is negative 6. So these are my two answers. All right. Any questions on that one? Awesome. Let's move on to the last one over here, number 4 in this middle section of notes. Okay. Draw on my wall. I'm going to think about isolating this term, the absolute value term. So I'm going to reorganize by moving the 7 to the other side. Notice how, again, I still have to isolate absolute value. I'm not done with that process, so I'm going to divide both sides by 2. Now I have accomplished what I set out to. Isolated absolute value, check. Now I can set up my two equations. 2x minus 8 equals exactly what was given, and 2x minus 8 equals negative 4. x equals 6, and x equals 2. Two solutions. Any questions there? All right, let's move on to the last two problems then, number 5 and 6. All right, so just because I have fractions in 5 and 6, don't panic. The process is very, very similar. Here is my problem. It's inside of the absolute value, so I already have absolute value isolated in this problem. I just need to set up two equations. Now this is going to go back. Oops, this should be a -2. This is going to go back, so there's your sign flip, the 2 and the -2. Way back, we talked about what to do here. We're going to clear the fraction first by multiplying both sides by 3. Cancels here. And I get 13. Over here, I'm also going to multiply by 3. Add 7. And I get 1. Right? Let's do one more of these and then we'll be done for today. Again, thought process. Be consistent with following the steps. Do I have absolute value isolated? I do. I have nothing on the same side outside of those vertical lines. So my next step now is to set up two equations. 5 plus 2x over 2 equals 3. And 5 plus 2x over 2 is equal to -3. Sign flip. From here, I'm going to multiply both sides by 2. Then I'm going to subtract 5. Okay. 2x equals 1. 2x equals -11. Divide by 2. I get x equals 1/2. And x equals -11/2, which you can leave that way because it can't be reduced. Right? Now, I would like to show you, let me go back.